Now, just to finish off this brief look at coordinate geometry that we've been doing, just a couple more formulas. These formulas, next, just two of them, they're not actually listed in the syllabus, which I find a bit strange, because I think they are useful formulas, so I thought it was worthwhile looking at them. So that way, I mean, they're there. I mean, just because it's not in the syllabus doesn't mean you can't use them. And I think we have seen them before, haven't we? Perpendicular distance, yeah. So all right, our perpendicular distance formula, and the reason this formula is useful is because whenever we talk about a distance from a point to a line, we're always talking about the shortest distance, and that is the perpendicular distance. So the formula for that, well, there's random point, which we'll call x1, y1, and random line. It's useful if that's in general form for this formula. So we want the perpendicular distance. And really, if you look at it, the construction of it is, the top of the fraction is the general form of the line, but we substitute the point into the line. And on the bottom, it's just a bit of Pythagoras' theorem. I guess it makes sense because we're dealing with distance. And we're using the coefficients of x and y on there. The reason we have the absolute value sign is because, of course, you could end up with a negative number there when you substitute into the line, and distance has to be positive. It's useful for something like this. We want to find the equation of a circle. We're told the tangent is 3x minus 4y minus 12, and the centre of the circle is 1, 4. Now you have to remember a bit of geometry for this, but if you remember from geometry that the radius is always perpendicular to the tangent at the point of contact. So if we've got a circle, centre 1, 4, there's my line, the radius is always perpendicular to the tangent, so really we're just saying, well, the radius is the perpendicular distance. Once we know that, we should be able to get an equation for our circle. So we'll sub it into our perpendicular distance formula. So general form of the line on top, substitute in the point 1, 4 over square root of those coefficients squared, so 3 squared negative 4 squared, and we get 25 on root 25, which is just 5. So we now know the circle centre 1, 4, radius 5. So from what we saw when we shifted shapes around, we'll get x minus 1 squared plus y minus 4 squared's 25. So that's just one example of where the perpendicular distance formula can come in handy. If it has different signs for different points. So when you substitute into the general form, so as I was just saying, sometimes you get a negative number, sometimes you get a positive number. Will this be useful? Who knows? But it is a way of telling which side of the line a point is, or whether they're on the same side or opposite sides. Because if you think about it, there's our general line. We know any point on that line, sub it in, we'll get 0. But then on usually the right-hand side with these things, if you substitute in, you'll get a number that's positive, and the left-hand side you'll get a number that's negative. So if you wanted to check whether 2 points were on the same side of the line, you could substitute it into the general form. If they're both positive or they're both negative, you know, yep, they're on the same side. If one's positive, one's negative, you know they're on opposite sides of the line. Is that useful? Well, to be honest, who knows? It could be a very rare situation you use that idea, but it's something we could use. Here's another interesting one. If you want to find the equation of a line through a point and the intersection of another two lines, okay, the long way of doing it is solving the two lines simultaneously, finding their point of intersection. Then you've got 2 points, and then you go, oh, what's the equation of the line between these 2 points? And point slope formula, bang, away you go. Of course, that takes some time. So here's an example. We want the intersection of 2x plus y plus 1 equals 0, 3x plus 5y minus 9 equals 0, but it also goes through the point 1, 2. So let's do it the long way. I would solve them simultaneously. Just making the coefficients of y the same for this one. And I'll get that 7x is negative 14, x is negative 2. Sub it back in to get the y value. Okay, so the point of intersection is negative 2, 3. Now I'll find the equation of the line that joins those 2 points. So, got to find the slope between those 2 points, minus a third. Point slope formula. And then eventually we get the equation of the line. And it certainly works doing it that way, but there is a quicker way. Here's the idea. You'll notice I've got two lines there in general form. One of them I'll multiply by k, because here's the idea. We know the point of intersection must lie on the first line. So therefore, when I substitute it into the first line, I get 0. But it also lies on the second line. So when I substitute it into the second line, I'll get 0. So I know that the equation of the line must be those two added together, and I could multiply, well, I could multiply both of them by a constant, but really you only need to multiply one of them by a constant. So I'll just multiply one of them by a constant, and it must lie on this line. That's where the third point now comes in handy. Because now, so for our example, our two lines were 2x plus y plus 1 equals 0, and 3x plus 5y minus 9 equals 0. So they were our 2 points. I'll just multiply one of those lines by k. We also wanted to go through the point 1, 2. So I'll substitute into this and work out the constant. You see, what we've done here is we've created a general line that goes through the point of intersection. Now, whilst it's just k, which is random, those lines could be going at any angle going through that point. What we're saying is we now want the specific one that's going through the point 1, 2. So if we substitute that one in and see what k turns out to be, and then we'll have our line. So 5 plus 4k, k is minus 5 on 4. Substitute back in. There it is, but it needs a bit of tidying up, of course. Multiply everything by 4. Bring everything together. 7 goes into everything there. And there you go. We get the same line. Notice I didn't have to find the point of intersection to do that. So that whole finding the point of intersection, I've done away with. All I've got to do is substitute into this line to get it. So it's a neat little way of solving that type of problem. As I say, not in the syllabus. Don't know why. Because I think it's a useful little thing. But there you go. So 7e, just to be a couple out of that, but I've also then put some past HSC questions there as well, so you can see what sorts of coordinate geometry questions that they've asked in the past.